So the first presenter is from the Philippines, and his presentation would be on ICT-enabled food price forecasting system for food security in the Philippines. So please, you may start your presentation. Thank you.
Good morning, everyone. My name is John A. Bacus, and I am from the Mapua Malayan Colleges of Mindanao from the Philippines. And I'll be presenting to you my proposal, or our proposal, entitled ICT-enabled food price forecasting, food price forecasting system for food security in the Philippines. So the food price volatility poses a major threat to the food security in the Philippines, as stated by the Philippine Statistics Authority in 2025. According to them, the Philippines is the most food insecure in East and Southeast Asia. Similarly, according to Montaño 2025 in his paper, empirical studies confirm that the high volatility of domestic food prices, and also he found strong persistence and seasonal effects in price behavior from October 1994 to April in 2024. From the demand side, research shows that the Filipino households display relatively inelastic demand for rice, which is the income elasticity of 0.26, indicating that consumers cannot easily reduce rice consumption when prices rise, which intensifies vulnerability to price, as stated by Valera et al. At 2022. So the target of this proposal are primarily, first is to develop a predictive model capable of forecasting long-term food prices in the Philippines using the historical data and machine learning techniques. So the World Food Program has already the data the data available online, which is the data set had from the year 2000 to 2023, including the following variables: the date, the region, the province or the city, the specific market, price, the latitude and longitude, which is the place where the price is at, category, which are the cereals and tubers, the meat, fish, the eggs, vegetables and fruits, the oil and the fats, the commodities as well, which is the specific food, the unit price type, the currency in PHP and USD. So the specific targets for that one is we're going to use that existing data set from the World Food Program, which again includes from year 2000 to 2023. So the specific targets are to develop and evaluate predictive models for accurate long-term food price forecasting. So it is mentioned here the three classical machine learning models, the RF, the linear regression, and the gradient boosting. So, but also, we are going to use the ARIMA and the Holt-Winters exponential smoothing, or the HWES, which will generate the stable and long-term forecasts in the year 2025 to 2045. Also, we are going to analyze and regional and categorical drivers of food price fluctuations, which are the commodity type, the seasonality, and geography, to generate interpretable and policy-relevant insights. Next is to design and implement an ICT-based forecasting platform, which will integrate machine learning outputs into a user-friendly dashboard for our policymakers, our dear farmers, and the traders. And will also facilitate regional knowledge transfer and collaboration, sharing methodologies, the data sets, and the tools with the ASEAN partners that we had to enable adaptation in diverse contexts. So for us to be able to solve, so the solution for objective number 1 is to develop and evaluate predictive models for long-term food price forecasting. So as you can see, there is an overall framework that shows how we will be creating this project. So this framework of the food price forecasting system will begin by processing historical price data from the year 2020 to 2023. Then, we will use the feature engineering to transform new data to meaningful inputs. Like, for example, since we have different classifications, we will use one-hot encoding for the feature engineering. we'll use the classical machine learning models to evaluate the short-term predictive performance, and we will also employ again ARIMA and the Holt-Winters experimental exponential smoothing which are more appropriate for the modeling temporal trends and producing multi-year projections. So for solution number 2, we are going to assess the significance of regional and categorical features such as the commodity type, geographic location, and seasonality influencing food price predictions. So here, we'll assess how regional differences, commodity types, and seasonality influences food price behavior. As you see on the left, we'll show the average prices across the Philippine region. So from year 2010 to 2023, we can initially see that the average price in PHP is in the Mindanao and Visayas region, it tends to have lower food prices than in the Urbani and northern areas, which is, if you can see on the graph, no, the highest price belongs to a very urban area in the Philippines. So for the solution number 3 is we're going to design and implement an ICT-based forecasting platform. So we'll design an ICT-based forecasting platform that allows users to explore future food prices interactively. So this platform will show interactive dashboards, so you can see, that can select the region, the commodity groups, and scenarios, and we also display the system accuracy and also its metrics, the trend results, and the regional disparities. So what's its significance of this? So this will help and enhance the decision support, or will act as a decision support tool for government agencies planning food security interventions. And for solution 4, we will be sharing it with our ASEAN partners to promote regional replication and strengthen ICT-based food security collaboration. So what is its impact? So the system will empower the Philippine policymakers and farmers with timely AI-driven forecasts for stable food prices. It will strengthen national food security planning by identifying regional disparities and predicting future market conditions. And through its open ICT-based framework, the project promotes transparency, resilience, and data-informed governance. And ultimately, it contributes to ASEAN food system stability and the Sustainable Development Goal, number 2, which is the zero hunger, through collaborative technology-enabled forecasting. So the output or outcome for scientific, the project produces a validated machine learning-based forecasting model, which is capable of long-term food price prediction up to 2045, produce or introduce a novel ICT-integrated forecasting dashboard that demonstrates how AI and data science can be applied to food security analytics, contributes to the growing field of applied AI in the agricultural economics, which provides a transferable model for similar use in our ASEAN nations. For societal impacts, this project will generate an open access dataset and interactive forecasting tool that can be used by policymakers, farmers, and researchers, enables evidence-based decision-making, which potentially reduces impact of the price shocks on low-income households in improving food affordability. The platform also encourages data transparency and public participation in food system monitoring. For collaboration, the initiative establishes new partnerships among academic institutions, government agencies, and the ASEAN ICT researchers, opens opportunities for regional collaboration, joint research publications, and cross-border data sharing for food security. The model's open design invites future integration with our regional partners in ASEAN and beyond. So the project contributes to SDG number 2 and SDG number 9 through technological innovation in agriculture, and it lays the groundwork for a regional early warning system for food price instability under the ASEAN IVO framework. In the long term, it builds resilience, inclusivity, and innovation in Southeast Asia's digital food systems. So in conclusion to this presentation, the project will develop and evaluate a machine learning-based food price forecasting system to strengthen food security in the Philippines. It will also analyze regional and commodity level drivers of price fluctuations and integrate findings into an ICT-enabled dashboards for real-time policy use. And we using over the 100,000 records from the World Food Program, models such as the linear regression, the random forest gradient boosting with the ARIMA and the Holt-Winters exponential smoothing. We will use them to train forecast prices up to the year 2045. An interactive web-based platform will be designed to visualize results, simulate policy scenarios, and issue early warnings for potential price shocks. Scientifically, the project will advance the application of AI in agricultural economics and introduce a reusable ICT framework for food price forecasting. Socially, it will empower our farmers, traders, and policymakers through data-driven insights that enhance market stability and protect our low-income consumers. The framework will be adaptable for ASEAN-wide collaboration, promoting regional cooperation in ICT and food security analytics, and it will contribute to the UN SDG number 2 and strengthen ASEAN resilience against food price volatility. And that is the end of my presentation. Thank you very much for listening. Mabuhay, good morning.
Thank you, Mr. Bacus. So at this point, we open the floor if you have any questions for the presenter.
Thank you. Very interesting presentation because food, everybody needs food.
Yes, that I
Not
agree.
only in Philippines, also in Indonesia and everywhere. Now my question is, when you are talking about food, what kind of food you mentioned? Because in Philippines, the staple food, as far as I understand, is rice. But is it only rice, or you also include other type of food because it is different? Yeah.
Yes.
The situation might be different. The other staple food. The other one is that how you make the data based on the historical data.
Yeah.
How you include the what call it, the high changing situation today. For example, climate change.
Yes.
Or
Seasonal.
U.S. policy change and so on. How your machine learning can adopt that the changes. Thank you.
Yes, thank you so much, sir, for that question. So I agree with you that the staple food for the Philippines and for Indonesia, for our ASEAN partners, we have rice. But for the data set, we will include actually, since the World Food Program has a readily available data set, and in that data set, it already included the cereals and tubers. We have the meat, the fish, eggs, vegetables and fruits, the oil and fats. And those are just the major classifications. And under that, we have the commodities and each specific food that is already there, like specific meat. And for the second question, you also asked about the seasonal trends. What if there are changes from the policies? That is actually a really good question since this system is to inform the policymakers. So that is actually one of the goals, so that there will be no price shocks that will happen, and we will actually collaborate with them so that we could do what potentially we will for things that will happen to that one.
Questions. 3 questions. You mentioned about AI. So what will be your approach? Is it deep learning or is it reinforced learning?
Yes. For the years 2010 to 2023, initially we used the classical machine learning tools, and then for the future forecasting, we're going to use the deep learning.
Okay. Will it be short term, medium, long?
Long term.
Long term forecasting. So meaning you'll be forecasting for next year.
Yeah, initially we plan to forecast yearly or every 5-year interval.
Okay. I would like to suggest you may include short term, medium, and long term.
Okay.
Because you are talking about price. Long term will be a bit useless maybe.
Mm-hmm.
Who will be your target of this particular proposal? Is it the government or retailers?
Yes, that's right. For the policymakers, the retailers, the farmers.
And the last, going back to, is it going, what sort of food will be included in your forecast?
The food classifications fall under the cereals and tubers, the specific niche, meat, fish. and
Can I
eggs.
suggest maybe you look into the category of foods rather than the type of food itself? Maybe one is import dependent, because as a policymaker, I think that will be very important. Let's say you import all of maybe I don't know, wheat from certain countries. Maybe you need some a good forecasting tool.
Mhm.
So that's one. The other one is maybe disaster related. So
Yes.
then maybe you also have collaboration with your disaster agency,
Mhm.
maybe to predict future trends, typhoons, earthquake, volcano. So I think there will be two, rather than specific foods type, maybe types of what do you call it, disruptions.
Okay.
Thank you.
That is noted. Thanks so much.
Thank you. Any other question?
A short question, only. The other part of your proposal is food security.
Yes.
What do you mean under food security and the related from the food price forecasting and food security?
Okay, so this is under the food security, since it will help our policy and for the policy and the decision support for our farmers, for our low-income households. So we can actually, the government or the policymakers can recommend price controls or SRPs, the suggested retail products prices rather. They could adjust the importation volume, such as the pork, the rice, the onions. That is one. Also application for decision support. They could anticipate food shortages and coordinate early interventions, guide for the budgeting for subsidies or food programs as well, and they could also prepare in inflation mitigation strategies as well.
In my opinion, I think you should emphasize on the other part, how the research result can contribute
Yes.
to the food security. Yeah,
Okay,
thank you.
thank you. I will take note of that one.
All right. Still have 2 minutes. Yeah, I agree with the comments and suggestions of our esteemed members from the steering committee. Probably the message is that the price of food, that's the observable variable, but behind that there are many factors: policy, climate change. I would also suggest including local data. I understand the primary source is the World Food
Program. Yeah, actually that is the Philippine data
Program.
set.
All right, Philippine. Is that from the Philippine Statistics Authority?
Yes.
All right. So we could also include other factors such as local inflation. So what affected the inflation? So very interesting study and very much correlated to, especially contributing to the food security, which is paramount to everyone here, to all of us, actually. Last minute for other question. Yes.
Good morning. Yeah, it's a very interesting presentation and
Thank you.
very good. I just want to ask you about your strategy. You know, how could you bring all this to the government so that they could come in and give the policy away in terms of what you have found? I believe those at the government already have all the data. So how would be this project different from that? Thank you.
The first one is actually, this is the first step, the visibility of the project. So I'm presenting in front of you that there is a need for food security, and one of that is this one. And actually, there are also fundings. Aside from, there are project calls in my country as well. So maybe try applying for that as well, so that they could hear, and this project could be more visible to them as well.
All right, another suggestion, get involved with our ministries, concerned ministries already, right from the start. So you would have their full support, even give you more data for your study. All right.
Yes, thank you so much.
All right, so thank you very much, Mr. Bacchus, for your very interesting presentation.
Thank you so much.
Okay, so the next presentation is from Cambodia. The title is Automating Farmer Interview Transcriptions with Speech and Generative AI, Low Resource ASR Approach for Cambodian Agriculture.
So a very good morning, everyone. My name is Lai Hing, and I am an AI researcher at Cambodia Academy of Digital Technology. And it's my pleasure to present my proposed topic on automatic farmer interview transcription with speech and generative AI, a low-resource ASR approach for Cambodian agriculture. And this project is conducted under the Institute of Digital Research and Innovation. So as a matter of fact, rice is an important staple crop, especially in Asia, where it is a key food source, and agriculture remains a cornerstone of Cambodia's economy. In 2022, about 36.6% of the workforce was employed in agriculture, contributing around 22% of the national GDP. In 2022, Cambodia exported approximately 330,000 tons of processed rice. Therefore, the Cambodian government supports the agricultural sector by investing and improving the agriculture productivity by promoting the irrigation and agri-tech solution. And to ensure the interventions are effective, the governments and local partners need to go to the field in order to interview with the farmers. With this constraint, the condition of the interview is located in a real condition which contains noise and overlap speaking. After the interview is completed, the social science researcher need to analyze this recording. They need to do the manual task by transcribe the speech one by one. And this process is very time-consuming, costly, and the delays in the data analysis. And this bottleneck significantly affects the timeliness and efficiency of the agricultural projects. Therefore, our goal of this project are, first of all, we aim to develop an automatic system that can transcribe Khmer farmer interview collected in the real field condition and can identify the speaker in the recording, specifically interviewers and interviewee. And then we aim to utilize generative AI to produce quick insight, analysis, and summarize from the long interviews. And then we also aim to build a management system tool that helps the social science researchers to organize, store, and retrieve their interview data. Following that, we also aim to provide a friendly web-based interface so that the user can upload the audio and directly obtain a structured output for their analysis. And finally, we aim to reduce the time of the data collection for the data analysis so that the field data can be used to transfer into the policy and decision-making faster. So this is our proposed system architecture. The process starts with the audio upload from the agricultural or social science researcher. So once the audio is uploaded into the system, the audio is processed into the voice activity detection. So this component will separate the speech content and the non-speech content. Once the speech content is separated from the non-speech content, it will be processed to the speaker diarization in order to identify the interviewers and the interviewees. And then the speech chunk of the interviewer and the interviewee will be processed to the Khmer automatic speech recognition in order to transcribe the speech into text. The transcribed text will be then processed into our generative AI component in order to generate the summarization and to highlight the key insights for the social science researchers. In order to implement this project successfully, we propose the timeline as follows. First, we will start with the data collection. We will collect the raw interview and focus group audio from the agricultural researcher in the field in order to ensure we align with the real condition of the speech. And then we will perform the data cleansing and pre-processing by performing the formatting and sampling rate conversion and noise check. And then we will segment the long recording into the small audio chunks in order to fit into our AI model. And then we will annotate our audio chunk in order to use it for the model training and model evaluation. Once we get the data, we will process with the model development by selecting the most suitable AI model for low resource ASR and diarization, tailored for Khmer language. And then we will fine-tune the pre-trained multilingual model on the collected field data that we have annotated. And then we will evaluate the model on the real test data set. And then we will develop our web application by designing a user-friendly web application for social science researcher and integrate the AI model, including automatic speech recognition, diarization, and generative AI into the web backend. And then we will implement the feature for uploading the audio and downloading structured transcript. And in the final phase, we will do the testing and deployment by conducting end-to-end testing with the real field user in order to validate the usability and accuracy. And then we will refine the models and interface based on the feedback as needed. And finally, we will deploy the system for the operational use in the research projects. So for the outcome, we aim to push the boundary of the automatic speech recognition for low resource language like Khmer, in order to demonstrate how generative AI can enhance the transcription and the data analysis. And we will deliver a user-friendly web application that the researcher can use to upload the audio and to obtain the structured transcript and insights. And we also expect to create opportunity for the joint work between AI researchers and social science researchers in Cambodia and ASEAN. So for the outcome, we will develop an automatic speech recognition pipeline tailored for Khmer farmer interview speech by applying in a low-resource language and to develop the user-friendly web-based application so that the researcher can upload and to retrieve the information for efficient key insight analysis. And we also create the opportunity for the collaboration between the ASEAN members because, for example, like Khmer is a low-resource language. It's very challenging to develop the large language model. So for the conclusion, this proposed research innovation offers the solution to reduce the manual workload for social science researcher and improving the efficiency of the data collection and data analysis. And the web-based application makes advanced AI tool accessible to non-technical user, bridging the gap between researcher and AI technology. And the approach is scalable and can be extended to other ASEAN local languages and domains. And with further collaboration, I believe it could serve as a shared resource for low-resource speech technology across the regions. That's all for my presentation. Thank you.
Thank you, Mr. Soklay. So now we open the floor for your questions.
Thank you for the presentation. Yes, it is important to know exactly the outcome of the interview. My question is, because here in your presentation you said you are using AI system like ChatGPT, Gemini, generative AI, and so on. I mean, how can you make sure that the AI you use is not producing the so-called AI generated errors? I mean, like the one, the study made by Deloitte for the Australian government. It's full with AI generated errors. I mean, several $100,000 study was rejected by the government, Australian government, because it is full with errors and false references and even false quotation. Thank you.
Okay. Thank you for your question. So I would like to confirm this as well. So we aim to develop the automatic speech recognition system by our own, and then we pass the transcript it into the generative AI for further analysis. So we will make sure that human will be in the loop. So first we will select a few generative AI. That's why I include different AI model, including ChatGPT, Gemini. So we will evaluate by using the human, and then we will use the prompt engineering because I believe in the context of the generative AI right now, if we input the right prompt, it will produce the right result. And this one, the result is the same, except we just want the AI in order to do the summarization for us. So it produces the short text from our fine-tuned transcription model.
So are you going to have it recorded, or is it going to be live, the dictation software?
So for this one, it's the offline one.
So this is the offline?
Yes. Because based on the experience, like we have the partners where they need us to develop the system for them, because they go to the field every week and they have perhaps 40 or 50 hours per week, so they need us to do the transcription for them.
Yeah, but you still need training for the model. How are you going to do the training?
Yes, for the model training, we will start with the data collection, because right now we have the data in in-house, but that one is not tailored for the field interview.
How many hours of data?
In-house?
Yeah.
So right now we have 150 hours for Khmer language.
I think in about more than 5,000 probably.
But in this context, we will use the large pre-trained model, for example, like Well2Wake, because it's pre-trained on 500,000 languages.
Those does not include also dialects, right? So those are maybe standard Cambodian.
Yes.
What about the transcription? Is it going to be in Roman, or is it going to be using Khmer script?
We will use Khmer script.
Khmer script. So that's another issue, right?
Yes. So we will tailor for Khmer first.
Right. So my suggestion is that the modeling itself, I think you need to put effort on the data sets.
Yes, you are right.
Definitely 150 hours is not sufficient, so I think you need at least a few thousand, so that's one thing. And then maybe you can make it online later, maybe that's much better. All right, thank you.
Okay, thanks.
How many speakers will be detected in your proposed method?
Okay, so for that one, based on the requirement of our partner, they mentioned like it's a one-to-one interview.
Oh,
so
only
it's
two
supposed
speakers.
to be two speakers, but there will be a challenging problem because they need to go to the field. So it's the open space, and sometimes there will be the overlap speaker.
Yes.
Okay.
Okay. Thank you.
Two questions, please. The first one is you talk about the noise, and between the group of the people, the user, the farmer, there is one is a voice and the other might be a noise.
Yes.
And how can you separate from this? And the second question is, you use generative AI to generate the output, and how do you evaluate the result, and what is the good and what is not good?
Okay, thank you. So I will answer the first question. So we will use the speaker enhancement for the case of the noisy condition and overlap speaker. And at the same time, based on the literature review, we will collect the real environment data set. That's why I have mentioned we have 150 hours in-house data set, but it's recorded in the audio and the continuous speak. But in order to make sure that our system is robust enough, we will ask the social science researcher which go to the field to use that data, which is the real data, which contains the noise at the same time. And I believe that Well2Wake will be robust enough when we fine-tune with that one on top of the speaker enhancement. And regarding the second question, I would like to answer that. I think I have answered that question already. So we will evaluate by using human in the loop, and we also select a few models. And in that case, we will just do the summarization and to extract the key highlights. So we will use the prompt engineering to ensure that it selects the relevant data.
Last question. Are you going to develop this from scratch, or are you using some other tools already available?
For the one, I will not develop from scratch. I will use the pre-trained model.
Is it Whisper or?
It's well-to-wake.
So if you use Whisper, then you can use transfer learning.
Yes.
Then you won't be needing 1,000 hours of recording. So you need maybe a few hundred will be sufficient. So maybe that's one way to cut short all these things. Thank you.
Okay, thank you for your suggestion. Because Whisper is also another candidate in my mind, but I need to do experiment between well-to-wake and Whisper.
I have a question.
Okay, thank you.
Since you're using the public generative AI, how do you govern the privacy and so on?
Okay. Thank you for your question. So there will be a trade-off. There will be a trade-off of that between the efficiency of the time using the AI and the privacy. So for that one, we will use the we will host it in our local server for that one. So we will use the open source generative AI. For example, like DeepSeek, we can host it in our local server. So we will choose different generative AI, because right now we have different generative AI. Yes.
Thank you very much. Have you? What are your approaches to verification or validation? Would there be other data sets that you'll be using to do some cross-validation, for example?
Yes, so for that one, I will mention about the two pipelines. So the first one is the automatic speech recognition system pipeline, which we will build by our own. So we will use the evaluation metrics, for example, what error rate and evaluate character error rates in order to check the goal data set and the reference. I mean, the reference and the hypothesis data set generated by our trained model. So based on that, we can see the accuracy of the ASO system. But for the generative AI part, we will use the human in order to check the result, whether it's acceptable or not.
Hi, here at the front.
Oh, sorry.
Curious question. Has there been a previous studies or research on Khmer ASR? And if yes, what's the performance of those studies?
Yes, so because I'm developing the ASR for my organization as well, so we use the statistical framework based on CARDI, CNN, TDNN, so the accuracy is 92%. But yes, but we focus on 5 different domains, including agriculture, but it's not robust enough when it comes to the continuous speech and the noisy condition. That's why we need to test with the state-of-the-art architecture, for example, like well-to-wake and Whisper.
I see. So that's the glass ceiling that you have to break, I guess, with your study. So probably you've mentioned that at least for the speaker diarization, it's not clearly shown here, but I guess there will be pre-processing as well of the audio. For example, noise removal if necessary. Would that be done as well?
Yes, it will be done with the speaker enhancement when it comes to the inference. But when it comes to training, we will use the speech which also contains the noise as well.
All right. Just a bit of caution, or probably you have done this as well. Sometimes pre-processing speech files, noise removal, or other processes can affect the intelligibility of the speech. So you might want to observe that as well in your
yes,
study.
because it will lead into the bias. Because let's say that if the data set is clean and we test with the noisy, so it will not perform as well as we expect. But if we train with the noise condition and we test with the noise condition, I think it can be robust.
Right, and I guess if your study becomes successful, which we hope will be, aside from agriculture, this can be, of course, applied to other fields as well, isn't it?
Yes.
We still have a minute. Any final question, suggestion from the floor? If none, there's the last one, all right.
Thank you. I am not familiar for your field, but I just know generative AI. Usually, there are many generative AI available, many programs, right? But why you select only ChatGPT? And when we do in the, like in medicine, right? When we poop, we at least use at least T program for poop our collect or not. But in your study, how many programs that you use? If it's not the same of your use in the one program like this, how to sure which one is correct? My question.
Okay, thanks for your question because we are also in the phase of the feasibility study. That's why we just select ChatGPT and Gemini, but we will do the evaluation if these two models produce the hallucination or the unexpected result. We will select another candidate for the generative AI. Yes.
All right, so thank you very much, Mr. Saklay, for your presentation.
Thanks.
Now we move on to the last presentation before lunch. All right, so the next presentation is from Vietnam, and it's on agricultural IoT system with edge intelligence. Please.
Good morning, everyone. Just my name is Minh. I come from the Vietnam, in the Port and Telecommunication Institution of Technology. This I want to say my topic is agricultural IoT system with the edge intelligence. So in this proposal is the background. We are recognize that in some current limitation of the agriculture IoT. As the since by recognized by my previous proposal, we can see is and some challenges and some issue like that the basic monitoring only. That the existing system provide data collection without intelligent decision making capability. So and second one is like a predict analytic, no real time autonomous control or predict insight for precision agriculture. So now we can see more about in for the farmer, like the language barrier, like limited multi-language support, restrict knowledge sharing across ASEAN region. And the last, we are focusing on is security vulnerability. That means in liquidity protection again involving cyber threats in distributed IoT network. So we can see is a critical gap. ASEAN agriculture needs the intelligent, autonomous system and that integrated expert knowledge with real-time IoT analytics when ensuring robust cybersecurity and multi-language accessibility. So that we want to move and some research object. We are define and some work practice in one of the object is multimodal AI integration. We want to develop and deploy multimodal mix of aspect MOE model integrated with the multi-language RAG LLM capability combine expert knowledge with IoT data analytics for the enhanced decision support across my want to develop is the Vietnam timeline and the English is my group. In the second one is the objective 2 is the autonomous as edge control is this theoretic and the technique we'll be focusing on is autonomous as the control. That's we want to build autonomous control system powered by edge intelligence, enabling real-time decision making, optimizing operation over semantic communication. We will be explain more about in the new tech on the semantic communication later. And the object 3, intelligent cybersecurity. As you know, the cybersecurity is a very, very challenging today. So I want to develop more and design intelligent cybersecurity framework adapt to the 5G or 6G network, ensuring data safety and protection against complexity using AI-driven anomaly detection. So that for our proposed method for work package 1, we focusing on is the multimodal MOE with the RAG LLM. That's the expected outcome. We want to try to build in robust AI-driven decision support system. It's an actionable recommendation for the precision agriculture and enhance reasoning, accurate linguistic boundary, and superior interference accuracy over general LLM. So, and the work package 2, focusing on in the autonomous edge control, we want to implement in some strategy like the develop as computing nodes for local processing. Is to make and the edge computing more and more intelligent. So embedded AI ML for autonomous integration and featureization is the main task for the farmer, and enable real-time pest or disease management. We want to conduct the field trial in the Vietnam, Malaysia, and Thailand. So we want to support in the party autonomously control system that adapt to field conditions in real time, even poor network connectivity. So in the work package 3, we focus on the intelligent cybersecurity. So we want to build a security framework with some component like that ML-based anomaly detection. It's the AI-powered identification and early detection. And second one is along with the blockchain, we want to make some data auditability and tamper-proof storage. It's to make privacy and to make a higher security for that. So to adapt to the 5G or 6G compatibility, that's we want to bring in this our framework security distributed IoT development on the next gen network. So we can see and some technical approach, our technical approach like that. For the lightweight scalable security architecture is our main purpose. And the second one is the automated detection response based on the ML or the AI model. More for the security, that's very important for the explainable when using AI or ML model. We are focusing on the AI for enhanced reliability for the decision. So, and the last is the most important. We all want to make more higher privacy aware data protection for as the edge device. So we want to validation in the penetration testing, simulation, and real work development across to the many countries like Vietnam, Malaysia, Thailand, and I want to invite to some partner to join with us. So in the implemented plan and timeline, we are trying to image that means at least 24 months for the project duration. So in this, and some partner join with us. In this one, beside and some institution and university, we are get and some mimosa tech company in the Vietnam they have, that's now this IoT system they can to cover for the 600 farmer. I think that's very convenient for the trial or experiment in develop and some the idea. So we are trying to image that so testing, validation strategy, and testing location in the Vietnam, Malaysia, and Thailand. In the experiment research design, is the control and environment testing, commercial farm development, and some multi-crop validation like tomato, vegetable, and fruit. So, and validation metric, we are trying to validate by and some decision accuracy and response time, and resource optimization, water, fertilizer, engineer, and system reliability and uptime and security detection risk. So, in scientists, technological impact, we are focused for as a four category. It's the one to view as a novel MOE architecture. So as you know, and the experience of the farmer, the different between among the country. The question is, and how to integrate it in this our database, and how to train it, and how to make it in reliability. So we are want to using and some multimodal mix-up experts model for the farmer expert knowledge with the heterogeneous IoT data and in context aware reasoning superior to linear LLM agriculture domain. So and second one is the edge intelligent advancement. So we are want to try to develop and some tiny ML model for the resource constraint device is enabling responsibility agriculture system with the poor connectivity. As you know, and some farm is located in the rural. So we need and so a lot of the transmission to between is the, for example, the center is the cloud to the edge computing. So that's we are try to define and try to make and some new communication like the semantic communication. I think it's just a very favor with the agriculture because and sometimes we are do not need to know the exactly is the parameter, and sometimes we see it like the fuzzy system. That means the semantic communication that may be adapt to this case, the scenario. So, and the third, we have always to continue working with the cyber security. It's a cyber security is my personal. So, I think that is security framework for the AI, ML, attack prevention, early detection, and integration with the 5G or 6G technology, with the AI enhance the reliability, addressing emergencies in the distributed IoT system. That's what we talk about in the edge device or edge computing. That means we can see that in the future we can work with the distributed system. Is it not centralized? Everything come to the cloud and to calculate and to give the decision, and sometimes it's a big delay or tolerant delay that's not adaptive with this case. So, and the fourth, we are want to multi-language knowledge transfer is a cross-linguistic agriculture advisor breaking language barrier across ASEAN countries. So enabling inclusive technology adoption and knowledge sharing. So we are want to move in the project's output and outcome. I think it's this our project. We are hope that we can gas, and some scientific output like that. It's a novel technology, MOE, RAZ, LMM architecture, and TinyML for edge device, AI-driven cyber security framework, and open source platform. That's a free network monitoring tool for the agriculture is the IoT security. And we are trying to make a small case for the digital twin platform. It can be used for the predicted simulation system for resource optimization. I think that's can be. So, and resource publications that we want to make and some real and to try to make our idea and to confirm and validate by the scientists in the work. So, as last in our can see in societal outcome technology transfer capability between public data sets and policy recommendation. And I want to make a more and expand its collaborative over international workshop and want to invite a new partnership in the ASEAN country. So that's the last. I want after we have done my previous project from the IVO. It's on my time for the IVO support. So we are recognized and some key limitation from my previous proposal. So I recognize that in the key transformation is still if you get a new proposal. It's AI on edge, communication enhanced, security enhanced, and geographic expansion. That's it. So it's thank you for the attention.
Okay, thank you, Mr. Min. So at this point, we open the floor for your questions. So let me start. Mr. Min, just for clarity of the proposed system, is there a particular crop or produce which the system would fit into? Or would you cover several crops or produce?
Yeah. It's my main topic is just only for the two challenges. As the first of all, and how to enhance is the IoT system performance. The performance of the IoT system by and some supported by some AI and ML model. And the second one is security. As the second one, security, I got to know that it's the data set as knowledge and everything can be affected to is the cyber security. That means the cyber security is very important in this our project. Yeah.
Also, if I understand correctly, it means that somehow you intend to capture the intelligence of or perspectives from different ASEAN collaborators. So for example, from Vietnam, from Thailand, or whomever would be part of your study. Is that correct?
Yeah.
All right. Just a hypothetical question. What if there's a conflicting advice from one country to another? How would the system handle that? Just hypothetical. For example, there's a problem and that, or there's a certain concern. For hypothetical, Thai approach is this approach, Vietnam approach is this approach. But if you implement those two, it would seem conflicting. So how do you think the system would handle that situation?
That means you talk about in the difference between this IoT device or system.
Yeah, okay.
For example, Vietnam and Malaysia or Thailand are different.
Okay.
Okay. So that I think that as you know, in the device can be work different between the hardware operating system, but in the fact that we are focused just only on the based on model, this AI ML model, and you can plug in and to access over API, and that's maybe I think is, and sometimes we try to work with some different hardware, so in that's okay.
All right, please.
Yes, thank you very much, Dr. Huang, for your very good presentation on this. I just want to check with you a bit on how you could overcome the issue with the edge computing, and this is one of the issue about the power that you need a lot, and at the edge, the device is so small to capture. I mean, this is only meant for capturing the sensoring data, right? And then how would you have this issue, and now you want to implement the edge that has the AI at that, and this will also contribute to the power consumption that will be too much to be available at that very far end, So this is a very good project in terms of how you could overcome all these three, the edge computing, the cybersecurity part. Could you elaborate a bit on these ideas, how this could be different and
Yes.
overcome the issue? Yes, thank you.
Yes. Yes, thank you very much for the question. So that on the first thing, we are focusing in this as a device is a limited resource. So now we are can to do and by some way. For example, we can get an all of the data set will be training in the cloud. After that, we are sending to the model for the edge computing, for the edge device. So that's my model, like the teacher and student. So the teacher can to get a lot of knowledge, but in the domain of the expert, we are can sharing between and some edge device. So and the decision can be sharing and to evaluate by and some magic to get a right decision between some students, like it's the edge device. So that is the edge device. We are do not to cover all of the knowledge. That's the only the expert of this knowledge is localized. This device can care. So that is limited in to reduce in the complexity for the training, for the detecting, and something like that. That means we just to save and to reduce the power consumer. Yeah.
All right, so thank you, Dr. Min. All right, just a quick one, please.
Yeah.
It's scary because it's a very, very big project. Even multimodal MOE itself is very, 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 very big. And the multilingual RAG LLM itself is also very, very big. And the edge issues also is very big. So it's really 3 or 4 big projects here. Given the time constraint, which one is probably your best bet that you're going to do?
I'm very sorry.
Which one is your, okay, given the constraint, which one is your focus? Is this multimodal MOE or the RAG LLM or maybe the edge issues? Which one? You cannot have everything. Which one you want to do?
I think the project as it is too big.
It's too
so
big.
Given limited resources, which would be your priority?
Okay. So
the one from Philippines can be included in the multimodal MOE, the one that was presented, the first one just now.
Yes.
Okay, go ahead.
Yes. I'm very sorry. As you know, sometimes my proposal is very big because we had finished my previous project and success. So we get just thank you for the IVO support to and all those powerful and to make and we can do and something like that. So we can develop from this my previous project and to next project.
True,
That's-
true,
I think
true.
that's
I
fine.
beg to differ because multimodal MOEs, mixture of experts is very, very difficult.
Yeah.
Because one is you have to have the experts from multiple countries, and you talk about the conflicting advice that may happen. And also you're going to have experts from, let's say, satellite data, maybe disease experts. So again, experts can also be looking from different kind of perspective. It can be from different countries, different crops,
Yep.
different types of data. So that itself is also very, very big. I'm okay with this, but I think definitely need to be scaled down to make it workable. Thank you.
All right, so thank you very much, and let's give a round of applause to our speakers. So we hope that they would eventually translate into successful proposals in the upcoming submissions of the proposals. So thank you very much. That's the end of the session for ICT for